Uh, okay, dear all students, very good afternoon, everyone. Only 55 students are joined out of 138. So still, I have to wait for 2 more minutes because previous lecture was now only they left out. So take 2 minutes and all of you join fast, okay? Just for 2 minutes, within 2 minutes. Okay, dear all students, now it is 3:35. Already 5 more minutes I given to you everyone for join. Okay. Once again, good afternoon, all of you, and welcome back after a long time, near about 17 to 18 days. You are busy with your Java training, and all the department staffs are busy with the admission process. So for that, minimum 17 to 18 days, we didn't touch a lectures. So welcome you back again. Uh, Once again, good afternoon, everyone. So, dear all students, am I audible? My screen is visible to everyone.
Yes.
Okay, thank you. Okay. In the last lecture, we have started the fourth unit of your microprocessor. The fourth unit is only for minimum mode and maximum mode and read and write instructions. Okay. So minimum mode already we taught. Just for 5 minutes, I will refresh this minimum mode configuration. After that, I will go for maximum mode configurations. So entire your fourth unit, that is nothing but system bus architecture, is including only two main topics. One is 8086 minimum mode configuration and another one is 8086 maximum mode configuration. So and that lastly we are going to study what are the difference between minimum mode and maximum mode of 8086 microprocessor, and also that read cycle write cycle for minimum mode and read cycle write cycle for maximum mode. If we studied this much, this is for your top microprocessor. Okay, so just I have to refresh for 5 minutes whatever I taught in the last lecture about minimum mode configuration of 8086 microprocessor. So in that minimum mode configuration, at beginningly we have to use the 8086 microprocessor chips. So this pin configuration already you know all the pin configuration how we are going to be arranged, and along with this 8086, remaining three more chips we are going to use. First chip, that is 8284 clock generator we are using, and one more we are using 8282 This is for 8-bit latch purpose we are using, and one more 80 to 86 we are using for transmitter as well as receiver purpose. So the minimum mode configuration is used for only to send the limited data and to do the communication between human beings and the machine, nothing but the 808 microprocessor. So along with that, we are using first chip, that is 8284 clock generator. So this clock generator we are going to use it for to set, apply the clock's frequency to the 8086, and in that we are going to set and reset with the circuit and ready state to transfer the data to the clock generator. And here that 8282 we have to use it for the latch purpose, that 8-bit latch which is containing A0 to A19, totally 20 bits of address lines. So in the 20 bits of address lines, 16 bits are for data lines and remaining 4 bits are for that IP addresses. Totally 4 plus 16 is 20 bits address lines we are going to be used with the 8-bit latch, and that is given to the AD0 to A16 with 4 bits of extra bus high enable purposes. And along with that, 8282 and 8284 chips, we are going to use 8286 chips also. Here also we have to use 16 data lines, D0 to D15. Those are nothing but a data bus which we are going to give a data transmitter or data receiver and data high enable purpose. We have to use this 8-bit transmitter as well as receiver purpose. So this is entire things about the minimum mode configuration of the 8086. So in the minimum mode configuration, the transmission and receiving of data is not up to the mark, not it is limited to only a limited of data, not maximum data. So due to drawback of this, limitations of this, again maximum mode configurations they have to produce inventor. So that we are going to study now. So this is the entire about minimum mode configuration, and this is the explanations. Please all of you go through it. Already we have to cover. So now directly I will move to the maximum mode configuration. Okay, okay, almost maximum friends are login. Okay, thank you. So actual class, now I will start with 8086 maximum mode configurations. Please all of you be alert, be more concentrate onto the lecture. Okay, so here even whoever not complete understood minimum mode configuration, don't worry, all minimum mode configurations are comes in the maximum mode configuration. The actually maximum mode configuration is got birth because of some limitations of minimum mode configuration. Okay, so to recover that minimum mode, that one we have to overcome with the some extra modes that is implemented by maximum mode configuration. So in this maximum mode configuration, same you are going to use it one clock generator as 8284 chips and one 8-bit latch as 8282 chips and one more chip that is 8286. So these three chips you are used in minimum mode configuration. So only one extra chip, that is 8288, that is a bus controller you are going to be used in the maximum mode configuration. Remaining all are same. You go and check with the diagram. Remaining all are same. If they have to ask about maximum mode configuration in the theory exam, you have to write minimum mode plus this one extra chip, more than enough. So anyhow, again this time as per university rules and regulation, it is online only. Okay, so many people students are in the confusing with offline exams or online exams. So already our university is declared as it is online exams only. So don't worry, anyhow we have MCQ questions again. So here again, in the 8284 clock generator, which is used for the generation of the clocks with the ready state of the data by using set and reset with the clocks of X1 and X2 pins. So here you have to sending the ready state with the reset of data with the clock CLK to the 8086 microprocessor, and in the 8086 microprocessor is already reserved with 16 bits of data lines, and that bus high enable. And also here one more chips you are going to be used, that is 8282 is used for 8-bit latch purpose. Here 20 bits of address lines you are going to be transfer 16 plus 4, and that one more transmitter, that is 8-bit transmitter with 8286 chips, that is D0 to D15, 16 data lines you are going to be transmitter as well as receiver to the 8288. In the previous minimum mode configuration, those input and output are going to be transferred directly to the 8086, but the maximum of data, whatever we are going to transfer, the maximum of data, that is controlled by the bus controller. So for that, we are going to use 8288 chips for the bus controller. It means that maximum flow of data, maximum transform of data, we are going to be controlled by the 8282 bus controller. So this is only the one extra chip. This is only the one extra chip in the minimum mode configuration. So the maximum mode configuration containing a four extra chip, 8282, 8284, 8286, and 8288 microprocessor chips along with 8086 microprocessor. Okay, so this is entire things about the diagram. So now one by one blocks we will explain in detail. So here come to the explanation. So that is the clock generator provided by a clock generator, that is 8284 in the microprocessor. First chip, that clock generator of 8284 IC chips used for clock generator either on or off, and it provides the clock up to the signal series of pulses at constant frequency. So whatever the clock generator we are giving to the 8086 by in the maximum mode configuration, there should be a constant frequency is going to be enter into the circuits, and the synchronization of ready state in the clock generator signal, which is indicates that it is a interface to ready for the data to transmit, ready for the data to transmit into the 8086, and it also synchronizes the reset with the signal which is used for to initialize the system. And in this, there are two ways to providing as you were in the minimum mode configuration. That is nothing but so EFI. EFI is nothing but external frequency input. So in this, a pulse generator which can circuits can be connected to the external frequency input circuit, and that pin provides on external frequency to to maintain, to balance in the 8086 volt transmitting the data into the ready state. And in the second way, one more way, that is oscillator clock inputs. So in the oscillator clock inputs, it is an can be connected with across with the X1 and X2. So here X1 and X2 two pins are there, that is can be connected with X1 and X2 lines to provide a constant clock signals. One is clock signals and one is constant frequency. For the frequency we have to use EFI. For the constant signals we have to use X1 and X2. So here, and in both the cases, the output clock frequency is equal to one third of the input clock frequency. Output clock frequency is equal to one third of the input clock frequency, and it produces the 33%. One third means 33% duty cycle required by the microprocessor. So here the clock selection is done by the microprocessor chips with the F slash C bar. So if it is 1, then the input clock frequency through the EFI pin is going to be enabled. If it is 0, then clock signal is going to be enabled. It means that the input clock given through the oscillator inputs to X1 and X2. X1 and X2 is for the signal, and this EFXI pin means for it is a EFI is for means external frequency input is through the EFI. Okay. So these two conditions, it will be works on the clock generator. So next, in the 8282 latch, it is a 8-bit latch, and it is used for to address from the multiplex address and data buses. So in the latches, they are required for 20 bits of address lines, and the algebraic logic enable ALE is connected to the STB, that is stove. STB is nothing but it is a stove of latch, and that ALE for this latch is given by 8286 as well as 8282 bus controller. So that main latch functionality is to give the feedback to the 8288 bus controller to control the data flow. And also whenever the stove and AL is equal to high, or we say it is a 1, or we say it is a on, the input is latched and transferred to the output state. So here that entire stove and ALE, which is 0 or low, then that it is discarded, means the data flow is stopped and not accepted to, data is not entered into the latch, that is going to be totally stopped. The stove and 0 or the stove is 1, high or enable. High means that is transmitted, and 0 or low means that is stopped, not going to be enter any data into the microprocessor. So here the data bus is given so 8286, because that 8286 is used for data transmitter as well as receiver. So in this data transmitter, there are 8 bits. 8 bit is for data transmitter and 8 bit is for data receiver. So the two 8-bit transceiver are needed for data bus. So in that, it is enabled through the signal while direction of the data is controlled by data transmitter or the data receiver. So these two signals are connected to a output enable and transmitted respectively of 8086. Same way how we are going to be used in the minimum mode configurations. So the data enable and the data transmitter and receiver, DEN in the sense data enable, and DT bar R bar in the sense data transmitter receiver signals are given by 8282 bus controller. So the main functionality of 8282 is going to be control the all the things the data flow in the buses. So in this we are going to be used here some of the table, that is data enable with 011, and data transmitter or receiver with 01 with the x of the first bit. So 0 x in the sense what, it may be either 0 or 1, both the cases. Okay, so if it is 0 or 1 case, transmitter and is discarded or disabled, and 10 means receiver data is enabled, and 11 means transmit data is enabled. This is the case what we are going to be used in the maximum mode configurations of bus controller for data enable and data transmitter and receiver. So here in the control signals, there may be a one more tables we have to made for the three inputs 0 0 2. There are three inputs means 8 0 to 7. Okay, 4 plus 4, total 8 bits. Interrupt acknowledgement, just it is for your kind information. Okay, so for that interrupt acknowledgement, read input and output ports, write input and output ports, halt, that instructions fetch, and memory read, memory write, inactive purpose, these are going to be used in the sequences. That is the processor state in the input of 8088 that chips for the bus controller. So that INTA in the sense what, if all these are 0, then interrupt acknowledgement is occurred. If it is 0 0 1 state of input, then that input read complement is going to be enabled, and 0 1 0 means that is the right input port, which is right complementary allows. So if it is 0 1 1 halt means no condition, no things is going to be enabled. So instruction fetch is for memory, right, and data complementary. Same way for 1 0 1 and 1 1 0 for memory right, as a right hand read, and last one it is inactive for none. So nothing is going to be happened here in the all high conditions. So this is all about uh, maximum mode configuration of bus architecture, all about maximum configuration of bus architecture. So once we studied minimum mode configuration as well as maximum mode configuration, we are going to be differentiate between these two. So one differentiate list already I prepared and I transferred these notes to all of you. So here students, difference, there is a list of difference between minimum mode and maximum mode configurations. So here I have to make totally nine differences. Okay, 8 differences more than enough. So I prepared nine differences for minimum mode and maximum mode. So just I will go through it. And this difference, this table is very, very important as your POE, overall examination for practical overall examination. This table is very, very important. So for that purpose, I prepared a well table. Please all of you go through it. So now I will go through this table. There is a minimum mode, one column I made it as, and one more column, maximum mode. Okay. Okay, okay. There is a network issue here. Okay, fine. So here, in the minimum mode configuration, now I am going to explaining the minimum mode and maximum mode configuration. So in the minimum mode configuration, it is a uniprocessor mode, which is in the 8086, but the maximum mode configuration, it is a multiprocessor, because 8086 we are going to be used along with 8088, we are going to be used along with 8086 and other processor in the circuits also present. Okay, so in the minimum mode, we have to use MN or MX bar pin connected to VCC, but in the maximum mode configuration, this MN and MX bar pin is going to be connected with ground. This is the one differentiate. Please, all of you, you have to note down it. So again, here that ALE for latch is given by 8086 itself, and here in this ALE for latch is given by 8288 bus controller. There, because that 8288 is extra, one more chip is available, but that is not available in the minimum mode configuration. So the data enable and data transmitter and receiver are going to be done with the 8086, but it is done with 8282 in the uh, maximum mode configuration. So here in the direct control signals, that is memory, input and output, read and write, that is ready and write, all produced by the 8086. But here these all are produced by S1, S2 and S0. So S0, S1 and S2 signals are there. So that is generated in the maximum mode configuration. And the control signals of memory input output and read write are decoded by the 3 to 8 decoder IC chips, but here we are going to be controlled by S0, S1 and S2, requirement decoding by 80 to 88 bus controller. And in the seventh point, the bus request and grant is handled using the hold and hold acknowledgement signals we are going to be grant. But here in the maximum mode, the bus request and grant is handled using the request and reject signals. That is request and reject signals. So here in the eighth point, the interrupt acknowledgement was produced for interrupt acknowledgement by using the 8086. But here we have to use it for 8288 in the interrupt acknowledgement. And at the last point, ninth one, so there is a one memory chip, so we have to use it, that is 74138, doesn't require a clock. So in the minimum mode configurations, we have to use this uh, uh, chip that is not requires a clock, but in the 8288 needs a clock for 8284 clock generator. So because there is a no clocks is present in the 8288 microprocessor chip, for that we are going to be used in the 8284 clock generator. So this is the very well defined table I have to prepared for you. Please all of you go through this minimum mode and maximum mode configuration. So after that, at the last point in the fourth unit, at the last point in the fourth unit, there is a system bus timing for read and write operation for the minimum mode and for the maximum mode. There's a read and write operation in the bus timing, system bus timing for minimum mode and maximum mode. So this one we are going to be explained in the lab programs because that signals are going to be formed. So this is the minimum mode read cycle signal and it is a minimum mode write cycle signals. This is for read and this is for write. And one more, the maximum mode read cycle and maximum mode write cycle. So read cycle, write cycle for minimum and same way read cycle and write cycle for the maximum. So this is for bus timing of read and write operation. So why we have to use it means bus timing means, so because of nowadays plenty of data, more data is available in the market to transfer that. Each and every second is also very important for to transfer the data. So for this, whenever the processor is ready to initiate the bus cycle, it appears a pulses and that really doing the even before following that. So in that really the address bus high enable BHE memory input and output and data enable and data transmitter and receiver must be stable. So for that the data enable is high and the data transmitter and receiver is low means 0 for input and for output it should be 1. Data transmitter and receiver is 1. So for that we have to make to form here for the minimum mode of read cycle and minimum mode for write cycle. So that is data enable, write, read, data transmitter and receiver, memory input and output. That is ALE and it is the address lines. So it is a address data. These are the data lines AD0 to AD15 and AD60 to AD60. That is the address lines. So here we have to use the clock. So for that input mode, for that minimum mode read cycle, minimum mode write cycle. So there is a what totally two cycles T1, T2, one cycle and T3, T4, one more cycle. That is entire. So here to here 90, here to here 180, 180 to 270, 270 to 360. So total one cycle. That is from 0 to 1 cycle how the data is going to be formed. So just one diagram I given to you for minimum mode read cycle and minimum mode write cycle as well as maximum mode read cycle and maximum mode write cycle. So this data just you go through it, this diagram. So this one we will go with lab programs. So on the kit, I will show you one experiment on minimum mode and maximum mode for read and write conditions. Okay. So this is all about your fourth module. Uh, so some more questions also I have to made it as from your previous question paper. So these questions also you have to just carry it out. This is more than enough. So 10 questions I have to prepare for this. Just you have to go through this entire module. So dear all students, this is about your fourth unit. So last one lecture I handle and this one lecture, two lectures. So actually this is one of the very smallest unit. So just all of you read it out. Only two topics: minimum mode configuration, maximum mode configuration, and next one is difference between minimum mode and maximum mode. And the last topic is that read and write for minimum mode and maximum mode. This one we have to go with the experiment. So Dear all students, by today's lecture, please all of you remember previous lectures. So by today's lecture, I have to completed total 4 units of microprocessor. So please all of you go through it. Okay. So yeah, uh, in previous days, actually in long back, so many people are asking some questions. So please, I will give you this 10 minutes time to discuss. If any doubts or any, are you facing any problems, and how was the ISC test one? Any difficulties, please. We have a 5 minute time to discuss. If you have still more questions, I will allow you a time up to completions of all your doubts, difficulties. If no more questions, then I will go for one lab experiment. That fifth lab experiment we are going to execute today. So before that, any doubts, please, we have a time for 5 minutes. Okay. Yeah, please. If no questions, then I will move to lab session. Okay, so very simple unit, this one, that is the fourth unit. Very simple. Please all of you go through it. And again, if you have any doubts, in the next lecture again we have to discuss. Okay. So dear all students, now I will move to the one lab session. That is the uh, program number 5. So as per syllabus, okay, just I will open now. Just a second. Yeah. That's fine. What we are going to do it? Syllabus. Okay, so hypertext syllabus is there. Just we have to go through this. Okay, just to find. Okay, dear all students, all of you carefully observe this. So, am I audible now? All of you, please.
Yes, sir, audible.
Okay.
Yes, sir.
So, this is the fourth unit, and that is system bus architecture. Today, whatever I have to cover, introduction and 8086 configurations. So, in that minimum mode configurations we covered, and maximum mode configurations today I have to cover, and system bus timings, that is read mode and write mode for minimum mode and maximum mode. So very small in it, just only for the 4 hours chapter is there, so we have to cover it. Now we will move to the lab session. So in the lab session, for okay, for lab session, dear all students, up to now I covered first lab, that is addition and subtraction of 16-bit number. I keep second one as a pending, and third program I covered multiplication of two numbers, and that 8 programs also we have to cover 8-bit division and unsigned numbers. Okay, so program number first, third, and fourth we covered by keeping second one as a pending. I have to give you a solution for that. So today I am going to use a fifth program, program number fifth, that is find a factorial of a number. So how to going to find a factorial of a number? So for example, all of you are aware of that. To find the factorial of a number, so here uh, one word pad. I will open you and I'll show you. So okay. So how we are going to find the factorial of a number? That is n factorial. For example, can you tell me what is the 5 factorial value? So here, for example, there is a number 5. Factorial of 5 is how much? Can you tell
120.
what is the 5 factorial value?
120.
120.
Okay, how we are going to calculate
120.
120 means how we are going to find the factorial? It means that 5 into 4 into 3 into 2 into 1, right? So this is the factorial of a 5. This is the factorial of a 5. So up to that number, we are going to be multiplied with each number by decremented by one number. Same number with decremented by one number up to reach last end smallest number 1. So this is the factorial how 1 into 2, 2, 2 into 3, 6, 6 into 4, 24, 24 into 5, 120. Is it? That is that 5 factorial is 120. So how to calculate 8 factorial? What is the value of 8 factorial? Can you tell me? 8 into 7 into 6 into 5 into 4 into okay, how much it is?
40320.
40320. Yes. Okay, maybe you have to calculate, you have to multiply these much numbers, and you have to get the factorial of this number. So this program, we are going to find the factorial of this number by using the microprocessor program. That program I will give you just 1 second. I will transfer you that program code, how to do this, how to find the factorial of a given number, to find a factorial value. So here, just 1 second. Yeah, fine. I will transfer you code of this in the microprocessor group. In the microprocessor group, please all of you go and type and send me the output screen. Okay. So along with that, I also give you the just a second. I'll transfer you code for that. Yeah, fine. Okay, all of you come to the microprocessors group. In that, I dumped that code. Please, all of you go and type. Whoever already practiced, you go and type. And whoever not practiced, I also showing here. You have to open your TASM and start to type this program. So this is the program number 5th. To find given to find a factorial of a given number. Yes, be fast. So I'll give you 5 minute time. Go and try. Up to 5 minutes, I will give you the output. I will give you the solution. So within 5 minutes, all of you go and try this program. At least you have to type this program in your TASM software. Okay. Here one, I am facing problem in the program when we press F9 or F7 till up to answer. Then program not stopped at answer. It will automatically close and comes on desktop. And suppose when we successfully complete our program, when we press on run and it will execute, then I am not able to press any tab which is present on top of the compiler window. So dear students, that 29922, please what you do, you go and reinstall the TOSM software, whatever I provided. So with any one of the windows, any of the windows, okay, already I given you. So what you will do, this problem is occurred because of your TOSM software is not installed properly. Okay, your TOSM software not installed properly. So what you will do, slowly, very slow, don't click that means okay, don't click fast. Okay, slowly you have to click it, and then you will get the solution, no problem. Only it is the installation problem. So for this, uh, it is because of installation problem. Okay, so you have to again uninstall and reinstall again. Okay, fine. Okay, anyhow, uh that's fine. So this one you are going to be type. Okay, anyone got outputs? How you completed the typing session? So please all of you type it fast again. 2 minutes I will give you. After that I will give you the solution. Okay. Yes. Okay. So dear all students, uh, I will open my TOSM. I'll show you how to do the execution. Okay. So please, if you have to type it, if you are getting output also very good. Just you have to. Okay, again, there is a network issue here. Okay, dear all students, am I audible, right?
Yes, sir.
Okay. So now I will show you how to execute that program. Who have done it is well and good, and who are not done, please all of you carefully observe the screen. Okay. So that program first edit file. I have to given this program name as a factorial fact.asm. The name of the file is editable file is fact.asm. So this is the program, whatever I given you. So this is the program, dear all students. Okay. So data segment, in the data segment, I have to take one number. So I am going to find the factorial of a number 7. Any number you have to take as your convenient. Any number you have to take. Okay. And one more thing, this is the 0 value. So here, and next to the code segment, in the code segment, we have to write the program code here with a AX register with a initial and data that is transported to a data segment. So this is the code of the program. Just I have to save this program. Just I have to save this program, and we are going to be use the TASM second command TASM fact dot asm enter. So here in this program, no error sign, no warnings. Next we'll go to the third command, that is t-link fact.obj. Third command is t-link fact.obj. So here you have to getting with on no stack. So again last command td fact.executable file exe. So here in this you are going to click on OK this. This is the window. So dear all students, your factorial value, how it is going to be if we are giving a 7 number, right? So you have to go to CPU, click on this. Again, you have to press the F7. Here you have to observe because you have to dump the value of 70007 hexadecimal, right? Hexadecimal 7 value you have to taking. So with the beginning values. So here just press the F7 initial. See, now you have to observe here that is 007 because we are going to find the factorial of a 7 given number. Okay, so 7 how we have to write 7 into 6 into 5 into 4 into 8. So every time we have to decremented by 1 and multiplied. Yes, so here that 7 number is we have to dump it at the beginning. Next again press the F7. See, bx is also getting 7 number. So now the bx value is 6 because we are going to be decremented by 1. 7 into 6. Yes or no? So second is 7 into 6. Again you have to press the F7. So again the cx value we have to store 6. Next again you have to use this. Next is 5 number. Again decremented by 1. 7 to 6. 6 to 5. This is the step. Again you have to store it in the cx register. So cx is stored it by 5 value. Again it is go to next step. That bx is 4. So 7 into 6 into 5, 5 into 4. That is the fourth number. Again you have to press the F7. So again you have to press the F7. It will goes to the 3. bx is 3 and stored it into cx register. Yes or no? So again it becomes a 2. Again stored it into cx register. Okay. So here you have the last one to the 1. So how we have to moving? Decremented 1 by each time. 7 into 6 into 5 into 4 into 3 into 2 into 1. So this is the last step. So again press the F7. CX is pressing. Okay. So all of you observed here F7 after completion of the 1 that AX register. What is the value of AX register? 13B0. 13B0. So this is the hexadecimal value. This is the hexadecimal value 13B0. So in the hexadecimal value, the factorial of a 7 number is 13B0. I will show you how it is. So all of you remember this 13B0. So I have to execute here. So this is the output. This is the output of this program. Just you have to screenshot and I will send you. So dear all students, just I have to execute this program. Exit. Okay. So here, what is we are getting that? Okay. So here we are going to find all of you observed here on the screen. So we are going to find the 7 factorial, right? So what is 7 factorial is equal to 7 into, I think this is. Okay. So this is the value. How much we are getting this value? How much it is? Tell me 7 into 6 into this. Please, anyone?
5040.
Okay. 5040. So this is the what we are doing here. This is we are doing by uh, decimal, right? But what is the hexadecimal of 5040? So this is decimal value. So this is right. It is decimal value. So what is the uh, hexadecimal value? So the hexadecimal value of 5040 is equal to how much?
13B0.
This is the decimal, right? Convert this decimal to hexadecimal. How much you got? Hexadecimal. How much it is? It is nothing but 13B0. Yes or no?
Yes, sir.
Use the calculator. Convert decimal to hexadecimal. Otherwise, you use Google. That is see decimal to okay. Here only I have to given you convert uh, see 5040. How you are going to be convert? That answer is 13B0. Yes or no? So this output you have to got, that is 13B0. So it means that how to going to convert this hexadecimal 5040 to 13B0. So our output is 13B0 only. So it means that here's that. Okay. So this is our output 13B0. So we are correct. The 7 factorial in the hexadecimal is 13B0. So this is the program output. So I will send you this. Okay. As some students are uh, getting output. No, it is not. So here I will send you the output. Please you have to check it. Yes, very good. That 66520 is very good. Your output is correct. Uh, okay. And Okay. Some students, you have to please recorrect it. Okay. So your answer should be that output is 13B0. Okay. So dear all students, now it is our time up. So please all of you go and practice it. Already the program code is with you. So if any doubts, again we will discuss in the next class. Okay. So fine. Any more doubts, please? Okay, fine. I have to close my class lecture today's. Thank you one and all. After long back, again we have meet today's in the lecture. So thank you one and all. If you have any doubt, again you have to make me a text, and at 6 to 7 o'clock today, if any doubts, you have to come online and ask me any doubts. Okay. Thank you all. Thank you. Now you can log out. And if any doubts is there, free to ask. You have a time now. S good, very good. 44148. Your answer is correct. Very nice.